Ground fault circuit interrupters, or GFCIs, are generally designed not to cause problems for commercial equipment. However, certain exceptions exist. Firstly, equipment sensitive to voltage fluctuations can be affected. Some commercial equipment, for instance, computers and certain medical devices, exhibit sensitivity to voltage fluctuations. GFCIs, upon tripping, can introduce brief voltage fluctuations, potentially leading to damage to such sensitive equipment. Secondly, equipment that requires a continuous power supply can be affected. Certain commercial equipment, such as refrigerators and freezers, depend on a continuous power supply for proper operation. GFCIs can interrupt the power supply to these appliances, potentially leading to malfunctions. If concerns arise regarding the potential impact of GFCIs on specific commercial equipment, consulting with the equipment's manufacturer is recommended. They can provide insights into the equipment's compatibility with GFCIs. In many instances, GFCIs can be installed in a manner that minimizes potential problems. For example, installing GFCIs on a dedicated circuit specifically for sensitive equipment is a viable option. Additionally, GFCIs with a time delay feature can be installed, providing the equipment with time to adjust to any voltage fluctuations resulting from GFCI tripping. By implementing these precautions, it's possible to mitigate the risk of GFCIs causing issues with commercial equipment. When dealing with electrical installations, it's essential to adhere to relevant electrical codes and safety standards. While the 1999 National Electrical Code, (NEC), may not mandate GFCI protection for all kitchen receptacles, more recent editions, such as NEC 210.8, typically require GFCI protection for 15 and 20 amp, 120 volt receptacles in kitchens. Understanding these code requirements and their implications is crucial for ensuring electrical safety and compliance. The fundamental principle behind a GFCI is to detect imbalances in the electrical current flowing through a circuit. In a standard electrical circuit, current flows from the source through the load and back to the source along the designated conductors. A GFCI continuously monitors the current flowing in the hot or supply conductor and compares it to the current returning in the neutral conductor. Under normal operating conditions, the current flowing in these two conductors should be virtually equal. However, if a ground fault occurs, such as when current leaks to ground through a person or conductive object, a portion of the current bypasses the intended return path. This creates an imbalance between the current flowing in the hot and neutral conductors. The GFCI is designed to detect this imbalance, typically a difference of 5 mA or greater, and quickly interrupt the circuit, shutting off the power to prevent electrical shock. The speed at which a GFCI trips is crucial for safety. GFCIs are designed to trip within a fraction of a second, typically around 25 milliseconds, which is fast enough to prevent serious injury or death from electrical shock. This rapid response time is essential for minimizing the duration of exposure to hazardous electrical current. GFCIs are available in various forms, including receptacle-type GFCIs, which replace standard electrical outlets, and circuit breaker-type GFCIs, which are installed in the electrical panel. Receptacle-type GFCIs are commonly used to protect individual outlets or small sections of a circuit, while circuit breaker-type GFCIs provide protection for an entire branch circuit. When selecting a GFCI, it's important to choose one that is rated for the appropriate voltage and current requirements of the circuit it will be protecting. GFCIs are typically rated for 120 volts or 240 volts and for specific current levels, such as 15 amps or 20 amps. Using a GFCI with an incorrect voltage or current rating can result in improper operation or failure of the device. GFCIs should be tested regularly to ensure that they are functioning properly. Most GFCIs have a test button that, when pressed, simulates a ground fault condition, causing the GFCI to trip. It is recommended to test GFCIs at least once a month to verify that they are providing adequate protection. If a GFCI fails to trip when the test button is pressed, it should be replaced immediately. While GFCIs provide valuable protection against electrical shock, they are not a substitute for safe electrical practices. It's important to follow basic electrical safety guidelines, such as avoiding contact with exposed wires, using properly insulated tools, and disconnecting power before working on electrical circuits. GFCIs are designed to protect against ground faults, but they do not protect against overloads or short circuits. Overloads occur when the circuit draws more current than it is designed to handle, while short circuits occur when there is a direct connection between two conductors with different potentials, such as the hot and neutral wires. Overloads and short circuits can cause wires to overheat and potentially start fires. Circuit breakers and fuses are designed to protect against overloads and short circuits by interrupting the circuit when excessive current is detected. In addition to GFCIs, other safety devices such as arc fault circuit interrupters or FSIs can provide additional protection against electrical hazards. FSIs are designed to detect arc faults, which are dangerous electrical discharges that can occur when wires are damaged or connections are loose. Arc faults can generate heat and potentially ignite flammable materials, leading to fires. FSIs can detect these arc faults and quickly interrupt the circuit, preventing fires from starting. When installing electrical wiring in a commercial kitchen, it's important to follow all applicable electrical codes and regulations. These codes are designed to ensure the safety of electrical installations and to minimize the risk of electrical hazards. It's also important to use qualified electricians who are trained and experienced in electrical work. Qualified electricians have the knowledge and skills necessary to install electrical wiring safely and correctly. In addition to GFCIs, other safety measures should be taken to protect against electrical hazards in commercial kitchens. These measures may include using waterproof or water-resistant electrical equipment, providing adequate grounding, and regularly inspecting electrical wiring and equipment for damage. Commercial kitchens are often wet and humid environments which can increase the risk of electrical shock. Therefore, it's important to take extra precautions to protect against electrical hazards in these settings. When choosing electrical equipment for a commercial kitchen, it's important to select equipment that is designed for use in wet environments. This equipment should be waterproof or water-resistant and should be properly grounded to prevent electrical shock. Regular inspections of electrical wiring and equipment can help to identify potential hazards before they cause problems. Damaged wiring, loose connections, and worn insulation can all increase the risk of electrical shock or fire. Any damaged wiring or equipment should be repaired or replaced immediately. Proper grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker or GFCI and prevent electrical shock. All electrical equipment in a commercial kitchen should be properly grounded. In addition to these safety measures, it's also important to train employees on electrical safety procedures. Employees should be aware of the potential electrical hazards in the kitchen and should know how to avoid them. They should also know how to respond in the event of an electrical emergency. Regular training can help to ensure that employees are aware of the risks and are prepared to handle electrical emergencies safely. When working with electrical equipment, it's important to follow lockout/tagout procedures. Lockout/tagout procedures are designed to prevent accidental energization of equipment during maintenance or repair. Before working on any electrical equipment, the power should be disconnected and locked out, and a tag should be placed on the equipment to warn others not to turn it on. This helps to prevent accidental electrical shock or injury. Electrical safety is a critical concern in commercial kitchens. By implementing appropriate safety measures and following safe electrical practices, it's possible to minimize the risk of electrical hazards and create a safe working environment for employees. Understanding the role of GFCIs, FSIs, and other safety devices is essential for ensuring electrical safety in these settings. Regular inspections, proper grounding, and employee training are also important components of a comprehensive electrical safety program. It is very important to remember that electrical codes and regulations can vary depending on the location. It is crucial to consult with local authorities and qualified electricians to ensure that all electrical installations comply with applicable codes and standards. Compliance with these codes helps to ensure the safety and reliability of electrical systems in commercial kitchens.